Yo, what's up gamers? It's your boy James, man, back with another video, and today I'm going to be looking at the LRU cache problem. I'm going to be showing you guys the ins and outs of how to solve this problem in an interview setting. And the first thing we're going to do is by looking at the problem, and we're going to figure out how to actually approach this problem, the data structures that you need to solve this problem in O of 1 time complexity. So the way that an LRU cache works is, for example, we have two operations. We have a get operation and a put operation. Both of these operations are used frequently in the LRU cache. So for a get operation, we're going to return the actual value of the item that's on the LRU cache. So for example, an LRU cache could look something like this. And if we have a function called get int key, which is, for example, get key of 1, we're going to return the value at that key. So these keys can hold different values. So this could hold value 5, this could hold value 10, and this could hold value 9, whatever it might be. Given this key, we're going to return the value. So if, for example, if given key 1, we'll return 5. In a put operation, our input values are going to be a key and a value. If a key exists, for example, our key is 2 exists in this LRU cache, and we're going to update this 10 value with the value that's passed into this function. Let's say, for example, 5. To notice here is that in get and put operations, if the value is present in either a get or a put, we're going to take out this value and place it to the front of this LRU cache. As you can see, since a get and put was placed on this 2, we move that 2 to the front of the cache because it was recently used. In a situation where we call this put, and for example, we have a capacity, meaning that this LRU cache can only have a maximum of 3 nodes, for example. If we put a key of 10 onto this LRU cache, well, 10 doesn't exist on this LRU cache, so we would want to add it, but we can't add it because the restriction on the capacity would be violated. So the way that we handle this is that we take the least recently used item, which is our case 3, and we remove it from this cache, and then we add on 10 with a certain value onto the cache. So that's basically how LRU cache works. So let's talk about how we can actually implement this. And the best way to implement this, as you can see, is using a linked list. But instead of using a singly linked list, meaning that there's only one direction between nodes, we use a doubly linked list. Using this doubly linked list, it allows us in O of 1 time to take this value if we need to use it in some which way or form, and we can easily delete it out of this list and then simply push it to the beginning of the list. Another key data structure that we need to use is a hash map. Using a hash map, we can easily find out where in the list a certain value is in O of 1 time without having to iterate over the list to find that key value. So using that hash map, for example, if we wanted to find 10, we could just easily put in 10 into our hash map, and this would spit out some tuple of where our key value actually is. We can use a doubly linked list to remove items from the list in O of 1 time, and we can also use a hash map to look up key value pairs in that list in O of 1 time. Okay, now that we got that done, let's actually implement. Alright guys, I just went through and implemented a solution for this problem. The way that I decided to do it was I have this list here, the C++ list, which is by default doubly linked list of type integers, and I have an unordered map of integer, which would be our key, which maps to an entry, which is basically like a node in our linked list. And this entry has the value, which is the actual number value of that node item, and we also have a pointer to that item using the list iterator here. First thing we do in our constructor is we have this int capacity, and I'm setting my capacity, this cap equal to capacity. Then in my get function, when we try to get a key, I check to see if this key is present in my map. If it's present in the map, I erase it from this list using this iterator from this key value pairing, and then I push this key to the front of the list, and then I update the pointer to the front of the list, and I just return the value of the key. If it's not in the list, I return -1, as said in the problem statement here. For my put request, I do a key value pair. If the key is present in the list, I remove it by using this map key iterator. In this case, if what we want to find is not in the list and our capacity is already at the map.size, then what we want to do is remove the back part of the list. So I just say .back, and I remove that entry from the map because it's no longer needed, and I further pop the back of the list because it's no longer needed. Then at the end, no matter what, we're always pushing to the front of the list, and we update our value as said in this problem statement, and update the key value pair iterator to the list at beginning. Sorry, yeah, I did have some errors here in my code. I was using front here when it should be begin, because this actually returns the pointer to the beginning of the list, and I also just spelt this wrong. And as you can see, we pass the actual thing. I want to thank you guys for watching. It was a little bit of a rough run, but you know how it is with this YouTube thing. You start off and it starts off rough, but the more I practice, hopefully it'll get better. Hope you guys have a blessed day. Peace.